everyone, we're back. Another episode of CubeCast. Thanks for joining us. I'm Chester, and today we've got Weldon and Charl, and it's a great thing that Charl is joining us because today is Tech Questions for the CTO.
Just rolls off the tongue.
I have to tell you, when I saw the recording come up on my calendar, I didn't read record podcast. I read roast podcast.
Well, we're going to try not to roast our CTO today, but if we do veer into that territory, it'll all be in good fun.
We do run the risk of going deep into the waters here for some people, but whenever time I talk to Charl, I always get a little bit smarter. So if you can kind of suspend limitations and what can't be done or what I don't understand and just listen, kind of close your eyes and port yourself off to a futuristic, capable place, I think you'll enjoy this a little bit better. I almost view this as kind of like an eye on the future of tomorrow.
So to that end, Charl, what are some cool things you worked on before Cube? Talk to us about kind of leading up to Cube, some of the stuff you've done, gotten to do, and had your hands in.
Well, I'm trained as an electronics engineer, right? And so I actually was considering doing a PhD and didn't, because I kind of felt always attracted to getting results I could hold in my hands. And PhDs are great things when you're pushing into the absolute edges of knowledge, but in a way you are placing bets on things that might not come to fruition in 5, 10 or 20 years. And so some of my colleagues went that direction. I didn't. And so I've had the privilege of actually working on a lot of very diverse things over the years. So these include things like early days of machine learning, license plate recognition systems. And it's really interesting that a lot of the latest and greatest stuff in AI essentially is just throwing a heck of a lot more computing power at some of these ideas that we already came up with in the 90s. And Chester, I know you do a lot of audio production work in various settings. You've used digital audio workstations as an example. So we did some of the very first convolutional reverbs. This was before even audio plugins.
Okay.
Were a thing. And so for people that don't know, this is where you actually shoot what we call an impulse response of a hall, and you apply that on top of a sound so that it actually sounds like it's in that hall, as opposed to it being some kind of an artificial algorithm. Did some work with head-related transfer functions, which is kind of a bit of an old-fashioned term now, but that's basically signal processing you apply to stereo sound that makes it be three-dimensional. Did some antenna design stuff, did some accessory development for mobile phones, worked on internet over satellite systems, particularly for applications in like rural Africa. I mean, that at the time involved in collaborating with people at NASA. I've worked on health insurance systems, inertial navigation systems, transit announcement systems. These have been deployed in places like, Paris Metro, Chicago Metro, ferry terminals in Scotland, the Vancouver SkyTrain. So if ever you are in the unfortunate position of having to be emergency evacuated off of a station platform in Vancouver, that's probably coming through my system.
Oh my!
So it's been.
Let's hope that doesn't happen.
Yeah, totally. But I mean, it's crazy. It's actually hard to imagine the amount of technology problems that exist out there, and the number of people working on these things. Some really, really interesting problems out there.
The huge breadth of things that you've done. It's interesting, though, there is kind of this thread of audio-related stuff throughout that.
Yeah, I've always been fascinated by human communication, actually. And I mean, I'm saying that as an introvert, right? So... But yeah, I mean, communication, not just between people, but between machines, networking, that has always fascinated me ever since I've been a kid. My mom tells the story as an example of, 3 or 4-year-old me stringing, tying strings between yarn, basically, between furniture and things in my room, basically. And yeah, this is me making the connections between all the different things in my room.
Technology and the technology side of business is a little bit of a catch-22, because on one hand, it's the bells and whistles of what makes the deliverables actually deliverable. But on the other hand, customers don't always put a lot of thought into what goes on to create the technology and keep it current. So talk to us about how we take your underlying approach to technology as a CTO based on your background and what helps shape who Cube is through that lens of what you've become?
So this risks being very abstract. So I think I'm going to try and give you an actual example and do this by telling, let's say, a slightly apocryphal story of an amplifier and a balloon, an audio amplifier and a balloon. So, at the university, I studied at the Faculty of Electronics Engineering, was contracted by the Conservatory of Music to create a very special audio amplifier. And, you know, as often the case with these things, so not an off-the-shelf amplifier, right? But it's basically something that had to be designed for a very specific purpose. And so often the case with these things, the conversation starts out as like, you know, we want 1,000 watt output or whatever the number was, I forget. That output needs to be 100% accurate and pure, right? In other words, 0% distortion. It needs to be 100% power efficient, so, you know, not generating any heat. It should also weigh 0 kilograms, which fortunately is the exact same thing as 0 pounds, cost $0, and it's needed by yesterday. So, you know, maybe that sounds facetious, but I think a lot of us will you know, hear the echoes of reality in that, right? And the point is, this is often how things are conceived as first, because I think innately we all have this yearning for childhood simplicity of magic, perfect solutions. And of course, the laws of physics, the laws of thermodynamics, etc., they just simply do not allow that. I mean, the laws of thermodynamics have been paraphrased like, you can't win. You have to play the game, basically. And so the upshot is there are all kinds of trade-offs that have to be made between, you know, time and cost and customer feature desires and, you know, for this amplifier, loudness, purity of the signal, weight, the heat generated, and so on. So you can think of the laws of physics kind of creating boundaries or constraints as to what is possible, kind of like a balloon, right, that contains a certain amount of air. And so you can shape it by, you know, in one place, but that's going to trade off, right? You're going to have that, you know, shape expanding in some other place in the balloon. So in this example of the audio amplifiers, the electronics engineering department went back to the music department saying, okay, well, you know, here's kind of the shape of a balloon that, you know, we think makes sense for your case. And so this is basically the specs, right? The specification. And the music department looks at this, they say, yeah, this is fine, right? This is fine. So now here's an example of this balloon analogy at work. The amplifier gets installed. It meets the specifications exactly as was agreed. The music department listens to it and they go, you know, this output wattage that we asked for is actually not loud enough. So at this point, what are your choices, right? So do you want to trade more time, more money, more size, more electricity, more heat, right, in order to get a higher output wattage? And no, this is not realistic under those circumstances. And so this is how the engineers squeezed the balloon here. They kept everything roughly the same, except they added a very slight bit of distortion to the signal. Now, distortion sounds like a swear word to audiophiles, right? But it does have this effect of perceptually increasing the loudness that you get out at the same wattage. And as long as the distortion stays under a certain threshold, it's inaudible. It's not perceived as a quality degradation. So, in a way, you can think of this as squeezing the balloon so that you're getting more perceptual loudness, but the chaos part of it, like the trade-off expansion part of it, is being shaped into a thing you can't hear, right? This distortion part that you can't hear, and that is really at the heart of all engineering. Is we are aiming to squeeze the balloon and make the trade-offs in such a way that we maximize the things that you want to get, while we're kind of shaping the noisy, chaosy parts into places that don't actually affect you, or that you're not aware of, right? So there are many, many more examples of this. Like every time you read about things like a 24-bit 96 kilohertz audio converters with, oversampling or noise shaping, or even if you take something like the humble MP3 file, right, which is all about just throwing away data so that the file ends up being a fraction of the size of the raw audio. These things on the inside are actually kind of awash in noise and chaos caused by nonlinearities, quantization noise, compression artifacts, etc. And the brilliance in their engineering is that that chaos is shaped into the frequencies and the places where most people can't hear them. Doesn't mean they're not there or they weren't there, but they are shaped. So really, I think at the core, our job is figuring out how to squeeze the balloon, but also peering into the future so that we're kind of trying to make the right trade-offs ahead of time, right? So, I mean, technology is supposed to be a tool, right? So it's both about the technology helping you get your job done more efficiently, but also about having it stay out of your way so that you can actually focus on doing the job, right? So maybe a quick way to describe it is our job is to be opinionated about the technology so that the people using it don't actually have to understand or think about all of these many thousands of underlying, trade-offs and etc., which otherwise would all be settings, right? That you'd have to you'd have to configure.
But the downside is the better you're sort of opinionated to say we need to squeeze the balloon in this such of a manner for now and for the future. And so you make it work where people don't have to think about all those settings. And so then the better it works. The challenge is the less people think about it. And so that part's good. But I think what people don't realize or what they don't think about is that often takes much more work to make it seamless. Like in a way, maybe it'd be easier to just put up all these settings and let people, select them. But it takes more work to make it seamless and invisible and not intrusive to a workflow. So how do you juggle that sort of conundrum of we build this great seamless technology and the better it is, the more invisible it is?
Well, the funny thing is that, if you look at software as an example, often taking lines of code out is more important than adding lines of code in, right? And to follow on from my, my balloon metaphor, I mean, the better a job we're doing of squeezing the chaos into the places that don't affect you, right? The less you are going to think about it. And to us, that's quite gratifying. That means we've actually done a good job. So an example of this is if you think in software, right, there are two things that people want. There are specific features they want, things they want to be added because they think it's going to be beneficial, right? And then secondly, they want those features to kind of work together, right? And so all of this generally sounds like adding more lines of code to software. Now, a funny thing happens. As you add more lines of code, you get more defects. But those defects, their severity, don't just tend to increase in proportion to the number of lines added. They actually compound more and interact more. So in other words, this pushing for adding features actually also creates a risk, right, for the overall quality and reliability of the pre-existing features. So again, to make this real for people, I'll give you some examples. Like this is not totally current information, but kind of the last available information. Linux as an operating system is about 28 million lines. Best estimates for Windows, about 50 to 60 million lines. So twice as much, right? So which is better? I mean, that's a loaded question, and this can become an area of much religious conversation. But let me just simply say, it used to be the case, at least, that if we wanted servers to stay up for years, we would put Linux on them.
Yeah.
So is that a coincidence, right? Now here's an interesting example, right? 28 million lines, 60 million lines. So are you familiar with Chromium, the Chromium name, right?
Yeah, sort of the underlying technology under Chrome browser and under Chrome OS and things like that.
Yeah. So Chromium is essentially a web browser that is developed out in the open, and Chrome is just a is basically a packaging of Chromium. And then, many other browsers pull very heavily from Chromium. So Chromium is 35 million lines of code. Yeah, so it slots right in between. And I'll give you an idea of the scale here. Over 1,500 people at least have worked on Chromium. So want to hazard a guess at today how many open issues there are in the Chromium defect tracker. So these are not issues that have been shown up historically or have been closed off or worked on already, like issues that are known, documented, and recorded now that still have to be closed off.
You didn't give us any marker from Linux or Windows, but so, I mean, a lot.
One of the things I realized when I worked for a cybersecurity company in the federal space with the Department of Defense, there is more lines of code in a U.S.-made Cadillac car than there is in a fighter jet. Because again, it goes back to how many errors are allowed.
For that reason,
you can't go, oh shoot, got to turn it off and turn it back on, or no, that's life death. So there's got to be less code, and that code has to mean something.
Exactly. So the number of open issues today in the Chromium project is just north of 64,000 open issues, and so Chrome is continually releasing updates. I mean, every few weeks it's updating itself, right? So it's easy to assume these issues are getting closed off, and they are. But as more lines of code are getting added, more open issues are discovered. And so if you look over the course of time, the open issue count's not going down, it's going up, right? Now, it kind of creates a situation where that means it contains a heck of a lot of quirks inside. And so, so we kind of, when we're building web applications and things like that, we have to engineer around some of those quirks. And we just have to deal with the fact that there's been so much invested into it that, sometimes the standards don't really count. And we just have to make it work, right, with those deficiencies. So on our end, there are specific techniques that we use for our own development, to try and steer around these types of issues. So as an example, we spend a lot of effort in figuring out how to have fewer lines of code, how to split things up into different modules, even different products, so that we don't have interactions between these lines of code and these compounding defect interaction issues, right? We're continuously expanding the type of testing we're doing into new areas. But there's also the feature side of things. And there's some very well-known stories about Steve Jobs as an example. When the very first iPod came out, there was a press conference where this was shown to the press, and people were really excited and started, peppering Jobs with all kinds of questions like, can you make it do this? And what about this? And have you thought about this part? And eventually Jobs said, people think focus means saying yes to the things you have to focus on, but that's actually not what it means at all. It means saying no to the hundreds of other good ideas that there are. And then he went on to say you have to pick carefully, and that he is as proud of the things that he hasn't done as the things he has done. Innovation is saying no to the thousands of things. So that doesn't mean the feature requests aren't great ideas or don't deserve to be heard. But if the situation is that, if you want a situation where the core product is reliable and remains relatively straightforward to use, you have to put a lot of thought and testing in to achieve that. Another example, I mean, who of you had the first iPhones, or do you know people who got the first iPhones?
Yeah, early on, I
think I got 3 was my first, so I'm not 1 or 2.
So people forget in the early days, the iPhones had no copy-paste functionality. And particularly people coming from the BlackBerry world, etc., really complained about that. They kind of went, this is, sorely missing. And Apple just basically said, it's not there and it won't be there until we figure it out how to do it properly. without degrading the rest of the experience. And today you have the situation where Apple's really taken over that world, and BlackBerry's totally disappeared. But I would also add, if you look in more recent years, how complex smartphones have become, you can kind of see how difficult it actually is to always get this balance right.
What are some things Cube does that most people have no idea, one, that it does, and what work went into it to keep it that way?
So people assume or take for granted storing files on their computers, right? And so there are file systems like NTFS or FAT32 or basically the mechanics, right, that's built into the operating system for how it stores files. And so we've actually developed our own file system, our own internal file system technology. And this is not something customers see. They're not exposed to it, but it creates very specific benefits for us in things like being able to find duplicates of data and things of that nature. And so this is something we've done that people would have no idea. And it's easy with these projects. You have to be very careful not to spend so much time just building the perfect framework. It always has to be in service of the product, in service of the customer in the end. And so we do that. Kind of similar vein is, you guys are familiar with the cloud providers like AWS, Google Cloud, Azure, etc. I think a lot of people just simply assume that our servers are all in AWS, etc. They are not. We do use some cloud services from AWS, etc., but we tend to use technology very judiciously, because sometimes these things are just totally over-engineered. They are overcomplicated for what we need, so they don't get out of our way, basically, right? And, moreover, there are specific benefits. So there are things we can do because we actually run our own servers with our own, clustering applied over them. There are things we can do that, other technology companies just simply can't.
So what are some of your primary drivers for changing or upgrading technology platforms? Like what makes that tick inside of you?
Well, as I said earlier, the role of technology really is to be, tools for us to make our jobs easier, our lives easier. And part of this means getting out of our way so that we can focus on what matters. And so those are the same drivers for us internally, changing or upgrading our platforms. So we'll do it basically whenever the benefit that we get from making things easier or getting out of our way more will outweigh the overhead of making that change, right? So for example, we'll do it when it allows us to get to new features more easily, but often it's related to those earlier things that I was mentioning, because it's bringing security improvements or because it's bringing better ways for us to test or monitor better or isolate different systems better or maintain reliability better or help us be more productive or more efficient, etc.
So are there tools that you'd love to be focused on developing and moving forward simply because it's a cool tool set? Are there things you're like, I really want to do that because it's cool, because it's a neat tool set, because I think I could do something with that?
So it's always tempting to want to play with new technologies. And, I think we always have to be aware that we don't just follow the temptation, to play for the sake of playing. But certainly I have been very excited by a lot of the massive progress in machine learning algorithms recently. And, particularly in not displacing humans, but actually helping us as this kind of recurring theme, right? Helping us make our lives easier, helping us have more time in the day, get our jobs done more efficiently, and helping the tools get out of our way so we can focus on the important things.
So how do you go about keeping backwards compatibility or to make sure things under the hood don't break things for the customers just using the tools? Because people don't realize what all goes into updates and things going forward, but this guy wants to hold on to this device that he's had for a long time. I've got apps on my iPhone, that I used to really enjoy, but the guy who created it's gone. Apple's continued to move, and that app is gone forever. And it pains me because I really enjoyed it. It's gone.
Yeah. This is a really interesting question, and traditionally there have been two very distinct philosophies, and the biggest examples of these are probably Microsoft and Apple, right? So Microsoft has always held the position, at least in the past, that as Windows developed, it should forever be backward compatible with software as far back as possible. And so they put a huge amount of effort into keeping old things running. And many of those old things at the time were actually reliant themselves on bugs or quirks or unintended behavior. And so I was mentioning earlier the 50, 60 million lines of code. So many of those lines of code are specific to keeping specific pieces of old software running. And so the outcome of this is that it works to a point. You've kind of got backwards compatibility, right? But not 100%. And all the time they've spent putting into that, right, is time they've not been putting into other improvements. And so in a way, if you think about the continuous update to software, as an example, right, cryptographers discover new weaknesses in algorithms, right, and then security patches have to be released. It's like you're running on a treadmill. You have to run on a treadmill just in order to keep these things up to date. But what Microsoft is doing is, as they are running, they're not losing weight. They're gaining it, right, in the form of all this extra baggage that's getting added, right? And, this extra baggage leads to more settings in the control panel, more documentation for users explaining to them what to do. And so, this is a choice to hang on to that baggage. And so there's this bloat that's forming in the name of backwards compatibility. And the question is it worth it? Because it costs us something somewhere else. So if you contrast this with Apple on at least 3 different occasions have totally drawn a line and said, at this line, we are going to break backwards compatibility with everything that came before so that we can move forward with a clean slate. So these instances are when they went from the Apple II to the original Mac up to System 9, right? Then the Mac from OS X again. Right. But doing that is what ended up giving us the iPhone, right? So I'm not saying the one way is better than the other way, but in my view, this is something you have to be pragmatic about. And so it's the same answer as before. You have to look at this and say, are we going from 0 to 1, right? Are we going from nothing to something? Or are we going from 1 to 2, from something to something more? Then, in the 1 to 2 case, usually we are extending incrementally within our current frameworks, and backward compatibility follows from that. But if it's better to think of it as a 0 to 1 problem, right, then you should be able pragmatically to say, hey, if we can tackle this without bloat and allowing us to think about it newly, and we would get better gains in efficiency and productivity that outweigh the downsides of drawing that line, yeah, it should be an option, right? Just don't do it every 6 months. I think that's I think Apple is a great example here in the sense that their phones have the reputation that they still run the older software, right? Even though they're the company that in the philosophy has said, we will draw this line whenever we need to. So, and I think that is the pragmatic trade-off.
One of the things we talk about with customers is when to deploy MVP or minimum viable tool sets and when to wait until that next, further iteration. So this is almost more of a market idea as opposed to a technology idea. But is that like when to make that move largely dependent on the customer's appetite for being on the bleeding edge, cutting edge, or, mass adoption cycle of the bell curve? Because we see so many things coming right now, machine learning and quantum computing. Yeah. You talked about cryptography earlier. Quantum computing is going to make current cryptography just meaningless. What does that mean for people when they think about iteration? Because Apple has made a lot of money, as Chester has said, not being the first to market, but letting someone else have that cost and then coming along and iterating with something great. Take us through your thought process on that.
Yeah, and maybe it's how do you evaluate how that customer is on that bell curve of bleeding edge, cutting edge, mass adoption. So when we look at MVPs.
So rather than me explaining what an MVP is, maybe you guys kind of explain to the audience what you perceive the purpose of an MVP is, a minimum viable product.
Yeah, an MVP is when somebody comes along and says, like the amplifier, analogy, I want 1,000 watts and I want zero cost and I want zero weight and I want, 100% efficiency. And it's sort of like the old saying, pick any two, here's the three things, but it's even different than that because it's not just three things, pick any two. It's all these things. I want all these things. And then really what happens in our organization here at Cube a lot of times is you leading the engineering team come back and say, yeah, we're not going to do all that stuff. Like, what is the very core thing that the customer is asking to accomplish? And a lot of times it's not even how do they want to accomplish it, it's just what are they looking to achieve and what can we put together? So then you'll come back with, here's what we can put together to achieve that on a minimally viable execution. So it's the opposite of scope creep. It's compressing the scope creep.
Yeah. So I think an interesting example of this was if you look at the on-hold marketing industry as an example, when the original idea came up decades ago to, that this might be something useful for customers, how was it tested? Essentially the MVP there was a tape recorder bolted to a prototype circuit for interfacing. Its whole purpose is to solve the problem, and I hesitate to say in a quick and dirty way, but that's not necessarily a bad way to think about it, just to see if it's actually a problem that people care about, whether they, that's a type of solution that people care about. And so to answer your question, I think you have to think of there being different types of problems, right? So there are hair on fire problems. And I think you know what I mean by that, right? A hair on fire problem is and we've seen those, right? We've seen businesses go, I am going to lose my contract renewal if I cannot deliver the following solution, or the current systems we are using malfunction so badly that we're going to have to shut our business down, right? Those are hair on fire problems, right? Then, and in those cases, MVPs are commonplace, right? Because just the fastest possible thing that will actually make progress to put the fire out, right? Then you also get these, like I call 0 to 1 problems and 1 to 2 problems, right? So 0 to 1 problems are things that have not existed. They're new paradigms. Whereas 1 to 2 are things like incremental improvements. And so just to, throw some rough examples out there, like Elon Musk as an example, starting SpaceX was a 0 to 1 problem, reusable space rockets, right? Him buying Twitter, not a 0 to 1 problem. With both of these, it's very easy to fall into this trap of sitting in a vacuum, or rather I should say sitting in an ivory tower and contemplating the great white elephant that will change everything. But meanwhile, nobody in the real world out there actually cares about that, right? And so for the technology companies, the biggest existential threat, the highest opportunity cost, is spending a ton of effort building stuff that nobody wants. So the whole purpose of an MVP is to gather evidence when there isn't enough evidence yet. So, so that you're continuously validating that this is actually worthwhile. And so, often when customers ask us about, features or make product proposals to us, this is how we would go about them. And oftentimes it's about them wanting to flesh out their own product offerings, and we encourage them to do the same type of testing with, same type of experimentation with their customers. The military analog of this is the OODA loop, right? Which I'm not always very fond of like war metaphors in business, but essentially this was something considered to be really vital to decision making on the field, right? And it's this 4-step approach where you observe, orient, decide, act. And you just do that over and over and over again. And the whole point is decision making, that you filter on the information in front of you, you put it in context, you as quickly as possible make the appropriate decision, and you understand and accept that changes will be made as more data becomes available. So these two things are really basically the equivalents, right?
So aren't there going to be customers that are more comfortable with an MVP and those that really want to wait till the tool's fully built, or the whole thing is pretty and packaged and ready to go? And how do you determine? Because you talked about, well, the features that are minimum, or if there's a demand, and from my perspective as a requester, a lot of times it's like, well, I want it, so there's a demand, but how do you filter out the people that want it on the early side and can work with that MVP?
Before he answers that, just not only do people want to buy it, but also there are people who cannot sell something that does not exist. And one of the people that really impacted me with that was a sales leader I had at a tech company. He came from Cisco, and he had this whole series of ways he looked at, selling into the market, like one of those things, win every deal or make it so bad that the other guy loses when he wins it, But one of the things he said was he was tasked with, talking to ExxonMobil and saying, look, we want to develop this product. And y'all are probably the largest user of that product. If we built it, we haven't built it yet. Do y'all want to help us figure it out? And they're like, yeah. And so they bought in, paid money to help develop the product that was exactly what they wanted. So not only was it not an MVP, it didn't exist. It was vaporware, and they bought it. Like there are some clients who are all in of, yes, I want that, and helping identify those. But there's also a person who can sell that vision.
Well, the way I think about this is, first we establish, is it a hair on fire problem? Because they are, there are very specific ways of thinking about them. And then if they're not, there are some very specific techniques for how to ask questions. There are specific signals that I look for. For example, if the customer has already tried to cobble something together themselves from duct tape, right? That is a certain specific signal. But with regards to actually how to ask these questions, that's a broad area. And so what I would actually do is, for people that are interested in that, there's a book that I would recommend, which is called The Mom Test by Rob Fitzpatrick.
Yeah, this is something we've talked about internally. Sure.
Yeah, which really goes into this in great depth. And the premise very simply is, right, if you say to your mom, hey mom, I've had this, great idea for a new app that does this, would this be something you'd be interested in? You're probably not going to get a very useful answer to that, right?
I love it. Of course, son. You should go build it.
You're so smart. So how do you find out what customers want when sometimes they don't know themselves? I think we've all seen that.
Yeah. So, I mean, this is in a way the Henry Ford story, right? Which is, kind of potentially also an apocryphal quote attributed to Henry Ford, saying, well, if I asked my customers what they wanted, they would have said faster horses, right? Whereas, I mean, what he was actually doing was figuring out it was about getting to the destination faster, right? And I think a really valuable way is to have enough of a relationship with your customers that you actually have an understanding of a day in the life, as to what they're going through. Because without that, how can customers will ask for things in the form that they think you can give it to them, or in the form they think they're using it currently. But that's not to say that's actually the problem, right? And Mom Test the Mom Test book has a really interesting example of this, where these guys were pitching a system to the financial industry, to the finance industry. And I forget the exact details of what it was, but basically they were given this feedback. This product of yours, it really needs to include an instant messaging feature. And they were totally mystified by this, because it wasn't about that at all. It was about, crunching numbers and things of that nature. Why did it need an instant messaging feature built in? And so as they were looking into this, what they figured out was happening was that all these different analysts were working in Excel spreadsheets. And so doing different updates to formulas and different variations of data, and they were emailing all these or exchanging all these Excel files to and fro, and it was really difficult for them to keep track of which one was the correct one, the latest one, right? And so in their thinking, in the customer's thinking, it was, we need this instant messaging feature so that as we're passing around these spreadsheets, we can notify one another in real time that this is the one you should be using, right? So in fact, they didn't need an instant messaging feature. They needed a document revision management feature, which is, so, you see from this, right, how easy it is to build the wrong thing. And so, Steve Jobs saying no by default to new features is one tool that helps mitigate against that. Using, MVPs with the OODA loop to gather understanding and evidence as early as possible is another way, right, that guards against
OODA
this.
loop? Is that a cereal? OODA loop?
Say the words again for the acronym.
Observe, orient, decide, act.
Yeah, OODA. So
yeah,
OODA. It's funny you talked about Henry Ford and the faster horses, but he also kind of had an MVP with the Model T, where he said you can get it in any color you want as long as it's black, and they don't only sell black cars today. So obviously they decided at some point along the line that it was worth doing something different. Yeah. But sort of an MVP example there that made me think of.
Yeah, totally.
What are some of the emerging technology stacks that we're building on at Cube?
So I am curious to know, when you say emerging technology stack, like what do you envision that term as actually describing, right?
You touched earlier on, there's Azure and there's AWS and Google Cloud, and people just assume that we spin up a server in AWS and something happens and their stuff works, right? But that's not exactly how it is. And so when I think of emerging technology stacks, there's a number of times where you'll come to us and say, hey, we're now able to roll this service better because we've found this better way to do things. And a better way to do things isn't just, now we've switched from AWS to Google Cloud. It's a better way of deploying code or whatever you want to look at. So that's kind of how I think of emerging technology stacks.
Yeah. So the world in a way feels like it's speeding up, right? The rate at which new technologies and tech frameworks and even like languages, computer languages and things like that are appearing is just faster and faster. And so as part of my work, I do a lot of reading, in an effort to kind of stay abreast of these things coming out and looking at how other people are using them and the results that they are getting. And one thing it's become clear, I would say more so over the course of the years, is you have to have a certain amount of skepticism with cutting edge new emerging stacks, because it's a very common thing to see that people are inventing something to solve a specific problem, and then the community doesn't form around it eventually, and the thing just dies, right? And so if you've jumped ship or you've embraced it very heavily, you might have inadvertently painted yourself into a corner, right? And so we tend to be very judicious in our use. So if we see something interesting, we might adopt it very carefully, right, in a small area. And basically what we're doing is we're building trust, right? We are trying to see, is this a trustworthy technology? Is this actually something that's beneficial? And we'll find small ways to experiment with that. And so there are a lot of little things like that we do. And sometimes it's apparent there will be huge productivity gains. So as an example, we use a lot of Python. We've used Python, since before Python was even widely known, because, when I learned it initially, it was just so obvious that it was it was a force multiplier, right? Today, Python by itself is not a force multiplier to that extent anymore, because so many more people have adopted it now, right? But there are things, so like specific data pipeline tools we are using. There are specific, type systems, which, this gets a little bit in the weeds, but like, Pydantic and TypeScript and technologies of that nature. We have some judicious graph query language usage that we're using, right? So, I can get very specific about these things, and if people want to chat to me through email or online or whatever, I'm happy to go into the weeds on on some of these names. But we tend to form opinions pretty quickly around which ones are healthy ecosystems and which ones are to be avoided.
Well, one of the things you've talked about that I don't remember all the technology terminology names, but instead of spinning up a server and running everything on that server, for instance, you now end up running different pieces of an environment across different containers or different servers or things. And so it provides, edit blank here. Yeah. Survivability. That's it. So it provides survivability and things like that. So that's kind of what I had in mind.
Yeah, so this is an interesting example, right? Because there are a lot of buzzwords in this specific area. For example, you have like Kubernetes, you have EKS, you have those types of systems, and they're all great for their purpose if they fit your purpose. But at the same time, if you're adopting those things, you're kind of buying into a specific ecosystem, right? You are accepting certain overheads, etc., right? And so we use, again, judiciously the bits that we need, right? So we have judicious use of containers, we have judicious use of overlay networks to make all these disparate services communicate securely, and then we don't use actually Kubernetes as a container orchestration system. We use something that's much lighter weight, and it's proven actually great for
fewer
us.
lines of code.
I can speak to Charl's judicious use of stuff. When I came over to Cube, I came from the DevOps space of a company called CloudBees. It was a DevOps tool that was open source called Jenkins, and we had all the enterprise level tools. I'm like, hey, Charl, if you're not using this for this, you need to use this, because I drank the Kool-Aid. I believed in what we did and what we tried to sell. And Charles like, you get it for me for free, and I'm not using it. Now, he was much kinder in the way that he said that, but
yeah. And the reality as an example of that is what Jenkins would have done there for us. We kind of have that in our environment as part of our revision control system, right? So there are many ways to maybe this is not the best analogy. There are many ways to squeeze a balloon.
Let's stick to a single analogy type.
Yeah.
Can you give us an example of a customer-driven development, something we did that was driven by a customer, and also maybe example of a development that we brought in as a feature, something that's end user facing?
I've got a few.
Yeah, this is an interesting question, because I think at the end of the day, if your philosophy is that the technology is a tool, right, that is supposed to make your life easy, everything really is supposed to be customer centric. And so there are customer centric requests that have been brought by the customer, and there are customer centric requests that haven't been brought by the customer. And so, some examples would be hair on fire problems, right, which are obviously brought by a customer. And this is, oh, my previous technology vendor has gone belly up, right? Now my tool that I'm using to deliver this vital service to my customer is just, not available anymore. Those are actual things we've solved for people, and we've solved many. I remember one specific case where a customer came to us and said they were servicing a large retailer, and the retailer got a new head of IT and basically said, well, we don't understand why the delivery of this content can't be done through streaming. And the customer simply said to us, I cannot convince him otherwise. I will, this contract will go away if I do not have a way to check this box next to this requirement. And so, I mean, this is a great example of where we could have built something totally new, but instead we found a fast way to repurpose stuff we had already and virtualize it in such a way that it would tick that box, right? There's also the example of, I mean, I think we've talked in the past about Premier Technologies and their hardware as an example, and these customers being reliant on a cloud-based service that was going to go away. And so that's a hair and fire problem, right? But what people don't realize is some of those customers were using some of those tools actually in totally different ways to do totally different things. And so there were cases where customers came to us and said, we've been, I wouldn't say abusing because that's not fair, but basically to say we've been using this tool in a unique way to solve a specific problem. Now this is going to go away, but the problem still exists, right? And so where we've looked at that and we go, okay, we can accommodate this, right, by wiring up these modules we have in a specific way, right? So these are hair and fire problems. But some other examples where it's maybe been more, customer centric in terms of features that customers, it's not like they have a fire to put out, but it's like they're trying to get into a new market, or they're trying to, improve their ability to service markets. One example would be a music library that we worked with, who basically said, we want to build the world's biggest interactive jukebox. And we did that. We helped them with that. And I mean, it's quite an interesting example because through a set of MVPs, that was something that they learned. Actually, people don't want. It's other than
sounded like such a great idea.
In very. Yeah, it's a great example. If you go, well, why should I not be able to control the music in any venue or the ambiance in any venue that I go to? Well, it turns out that just doesn't motivate people enough other than in very specific venues. And so you see, I mean, how much time you could spend in having debates, etc., right, about building the perfect solution. And then, I mean, there've been examples where, customers have showed us how they curate playlists or manage playlists or programs, right? And kind of the way they audition, right? And then we look at this and we go, okay, there's actually a lot of overhead that they're spending with the current tools in terms of how many clicks they've got to do, right? And so if we just order things in a certain way and expose the screens in a certain way, it cuts down on the amount of time they have to spend by orders of magnitude. So these are all customer centric features, right? But then there are also foundational things. And so foundational things are things that customers don't necessarily see directly on the outside. They're not necessarily asking for them specifically, but they come because of observations we are making. And so this file system that we built that I was mentioning earlier, that's a great example of this, which is, well, we can see customers have a problem where they don't always know when they've got the same file but under different names in different places, right? And it's not that it causes for them a pain point there, but it's like a can they're kicking down the road, and they pay for it somewhere else later. And so then there are foundational technologies that we introduce because it sets us up for the future, right?
So in your course of development for things like that, do you use specific techniques or concepts like waterfall, agile, scrum? How do those fit in your world?
Yeah, waterfall is conventional long-form project planning. Works really well when you're building factories and buildings. Doesn't work so well for software because you exactly have this problem that, if you're working in a vacuum and, with a long-form project plan, and so you run your waterfall project for a year or 2 years, you get to the end, you've built this beautiful instant messaging system, and then you learn, well, what the customer actually needed was a revision
Yeah.
control system, right? So that means you spent 2 years and every debate and exploration you've had on how to make these trade-offs for this fantastic instant messaging system's all been for naught, right? It was totally pointless. So instead, you still have to have longer term directional planning, but you have to also do very, much like shorter time horizons, ongoing testing, ongoing experimentation. So this is the OODA loop, right? The MVP idea. And so agile, the term agile, is really just an umbrella term for this idea that you are doing experiments and able to adapt from that learning as it arises. Now, Scrum for me is a little bit of a swear word in the sense that it's one highly formalized version of Agile,
right?
Where it's like you've basically bought into a denomination of Agile that is replete with its own branding, coaches, certification, etc. Right?
Right on.
Yeah.
So where do you see the value or level of importance of pretty user interfaces or GUIs versus enterprise grade functionality and dependence? I come with my own experience on that, having a diverse background of software sales and experience. And obviously, when I worked at IBM, nothing we had was pretty. Meanwhile, we competed against in niche environments. Like we had a business process management software that took 18 months to deploy, and it was heavy use. It was ugly, it wasn't pretty, but it worked. But we competed against people that was the only product they had. And the user interface was amazing and it was easy to get installed and whatever. But which one could handle like military grade work? And IBM often won those, so the trade-off of making something pretty and consumer facing and something that people like, Apple has done an amazing job of making everything just easy and look pretty, and the gamification or appification of technology, well, it should just be easy and look pretty. Well, that's not always easy. So I'd like to hear your thoughts on it.
Well, I think the question you're always asking is like, who is using this, right? And do they live inside of this thing, or do they only use it occasionally? And I mean, occasionally might mean once a day, right? Or once a week, but they're not living it, right? And then what do they actually need to get their job done without the thing getting in their way too much, or having too many annoyances, or requiring them to think too much? And so in this sense, I mean, there's no difference between the idea of a user interface and you doing a physical job. Let's say you're working in a bakery and your user interface is the way the ovens are laid out, and the conveyor belt carrying the dough, and the mixers, etc. Right? And so if you think through it through this lens, sometimes having a beautiful GUI that imbues a certain sense of magic and joy to the user is actually key to helping the user get their helping the tool not get in their way, right? But in other cases, it can be an impediment. So one specific example of this is this idea of affordances in GUI design. And basically what that means is, if you look at a GUI, like, how do you know this thing is a button that can be clicked, or how do you know this thing is a card, right? That if you press, it's going to reveal more information, or that you can grab this thing and drag it around or connect it to other things. How do you know that without actually having to go through all of those attempts to see if it works? So affordances are these subtle little visual cues that are suggesting to the brain, this is a clickable thing. And in the more modern style of GUIs, affordances have often been taken out. They've often been kind of thrown by the wayside there, where they're not as self-evident as they used to be anymore. And what this means is it requires more thinking from the user, and the user isn't necessarily aware that they're doing that thinking. They just maybe feel the subtle sense of annoyance, under the hood. And so, I mean, the upshot is, people that use a user interface are tend to be, particularly the first time, or if they do it occasionally, they are very reliant on affordances or on kind of endemic pattern knowledge of what this typically looks like in, you know, other tools or similar tools. Then knowing what to expect is important, right? So when we're creating a new paradigm, right, or a new way to do things, and that might require new screens that people haven't seen before, it's actually quite, you know, tricky to convey how to use it if you're not purposefully adopting a style that the target audience has already got some familiarity with, right? So again, this by itself is you know, is an aspect of the balloon. So here's a really interesting example that will help give you a different perspective on this. If you guys ever played Nintendo Mario, Super Mario, one of the old Mario games, right? Yeah. So think of the very first people that played this, or the very first time you guys played this. How did you discover to play the game? Like, you know, if you jump in this place, you bump a block and then a flower comes out and it gives you super, like, how did you discover that? The process of that discovery is an affordance, right? That was built into the design of the gameplay itself, right? It was purposefully designed for you to discover it. So oftentimes modern pretty GUIs are not actually doing enough of that.
So where's Cube going with technology in the next 5 to 10 years? What's on our roadmap?
More pretty GUIs. Yeah, no, I mean, I'm both joking and not joking. I mean, I think there's a saying, which is, you know, first make it work, then make it right, then make it, you know, fast, pretty, etc. Yeah. And, you know, that's kind of often, you know, that kind of speaks to the core of the previous question as well, right? Firstly, it's just helping you get your work done and getting out of your way. And then, you know, obviously as we build things out, we learn more things about what users need. And so what I see in our future is there are, you know, more applications that are individualized but are integrated together. And so, you know, for example, people already know the scheduler, like the, you know, blends, there's a new bin sequencer tool, etc., right? So tools for managing playlists, tools for procuring audio. And I think you will see a much greater increase in the use of artificial intelligence / machine learning as tools to help you do your job more easily. So for example, the whole area of how do you store all your assets, your files, your collateral, doesn't matter if this is like recordings or, you know, I don't think people actually realize how big a deal it is organizing it, finding what they need. And this stuff is on the verge of a paradigm shift.
There have been times in our time here at Cube that I've become a buyer for the first time of technology. And a lot of times when in the enterprise space, you just take what's given to you, even though you want something else really bad. But I've become a buyer. And then for myself as a person, you know, I've bought technology. But I always try to go to someone who's a specialist. I have a friend who is a mechanic. I talked to him before I bought cars. You know, there's things people in the know inherently. So when people like me who are semi-informed compared to developers evaluate technologies, we're going to miss shortcuts that you take. What is a good way to evaluate technology honestly so that you can make a wise decision for your business?
So I'm curious what you mean by shortcuts in
things that you know from past experience that let you cut through the fluff. You know,
maybe the things that you see that are cutting past the pretty GUI. Just to harp on that a little bit.
like people don't realize for early days at Gmail, it looked pretty on the outside, but it was, you know, chewing gum, bubble tape, and, you know, it was not a good process in the back end. So
yeah, this is squeezing the balloon, right? This is so what when you say shortcuts, this is the squeezing of the balloon and the explicit trade-offs, right, that have been made by those engineers. And so I think the challenge is, if you want to assess those and you want to assess, do they make sense, right, for your environment, it kind of implies that you also have to have an understanding of every other part of that balloon right in order to have the holistic picture. And so, if the requirement is, you have to know the whole balloon, well, at this point, you're kind of trained as an engineer yourself, right? So I think what it boils down to is this is the reason why there is supposed to be a certain standard of ethics in engineering and, and in technology firms, right? And so that basically when you have an engineer saying, look, we've made the trade-offs this way, and it's based on our assessment of what makes the most sense for you, that you can actually trust that. Because that's what this question is boiling down to, right? Is how do you know you can trust that? And I think the reason that that's a question is because many companies today are not really good at the ethics part of this whole equation. So you feel that there are hidden agendas and things of that nature. And so I think in Cube our culture is such, and we've tried to be open with people and always stay on the right side of the ethics side. And I think that's my best advice, right? Is you were talking about an expert, right, that you talk to before buying cars. You have to partner with somebody that's knowledgeable, that has shown themselves to be trustworthy. I think it's really the only hope for this for this question.
If you don't know anybody, sorry, take your chances.
Yeah, 6 degrees of separation. You may not know anybody, but I'm sure you know somebody who knows somebody else who can point you at a trustworthy evaluator of tech, right? Or you know what I'm saying, right? This is not, it sounds hopeless, but it's really not.
Yeah. So what's an area in the sort of customer experience or telecommunications space that you see is ripe for disruption?
Well, as I said, I've always been fascinated with communications, and it strikes me communicating over a distance should be effortless, and it's really not. I mean, it's really funny if you think that most of us as kids, we learn to communicate through talking, right? Way before we learn to read or write. So it kind of feels like sound should be the most effortless medium of communication. But today's technology seems actually quite unable to leverage this. I mean, we are in a world now where the telephone fundamentally hasn't changed since, it was invented. Right. People are terrified now to make phone calls because they're anxious of rudely interrupting, the other person with whatever they're busy with, or of, navigating brainless phone trees, or of being stuck on hold for hours. So, I mean, people are not even leaving voicemails really anymore either, because they also don't want to be interrupted by other people calling them.
I don't want to listen to voicemails, to be honest.
Yeah, and then, I mean, when people do connect, it's like the first several minutes are going into, can you hear me? I'm not getting my headset to connect. And
that may or may not have happened at the beginning of this podcast.
So, so it seems like in our technology, we are actually vastly underutilizing one of the key of the 5 senses that we actually have to communicate, right? And so, instead as a species, we are trading this for all of these overheads associated with writing and reading and the inscrutability of the emotion that comes along with that, and kind of giving up the ability to hear human nuance, right? So I am convinced that there's a better way. I am convinced that there must be a better way, and that, we will see a lot of disruption. And in fact, I've made it my mission to find it.
Oh, that's going to be fun to be on the ride for that.
I think that you need to say in a more compelling way. Oh, that's going to be so much fun.
I am looking forward to that disruption ride. I mean, shaking things up. It's good.
I must say, though, I don't quite think of it in those terms, right? I think of it more like, I mean, Elon Musk as an example has the sense that we got to leave Earth for the survival of humanity, right? And some people will agree, and some people will disagree, right? And that's almost in a way beside the point, right? But I look at this and I go, man, it's like there's something fundamentally broken in human communication. where if we could somehow fix that or address that as a species, maybe it just puts us in so much of a better place, holistically speaking, right? Where, yeah, maybe that has business impact for telcos and things like that. These guys typically know how to take care of themselves, right? So we're losing too much sleep worrying about that.
So, what are some passions you have outside of Cube, and how do they influence you inside of Cube?
I have an affinity for water. I enjoy swimming. I enjoy kayaking. I find it a great way to clear the mind. I do a lot of good thinking in the shower.
One of my best
Or
decisions
even just
came in the shower. There's not a lie to that.
or even just like taking long walks. And I just, as I say, clearing the mind, I think is a great thing. And then obviously I have hobbies for sanity's sake, because even in technology it's easy to have all your hobbies be very highly tech centric as well. So I play the piano. My mom had the foresight of basically saying she wanted me to take music lessons, but not in a way where I had to play very formalized exams or whatever. So it would always be for enjoyment purposes, right? And so I've always gotten something out of that. I think there's a sense of work that you do towards a goal. There's a sense of achievement when you get a goal. And also I think it's given me in a way a bit of an understanding of what musicians are dealing with, and what creatives and audio creators are dealing with. And I don't know if it's clear from this podcast, but I consider engineering actually to be a very creative endeavor. This whole squeezing of the balloon and figuring it's I've worked with engineers as being extremely creative people in terms of things like shaping the noise into somewhere where somebody doesn't hear it, or using a specific scientific principle to do that. I mean, these are very creative applications in their own way. It's just a different type of creativity, right? I think as humans, we all strive to create things, to be creative.
Yep.
Congratulations for sticking with us and getting a little bit deeper look inside Charl's head primarily, and some of the decisions he makes and the things that he deals with, and the ways he thinks about things, and how that helps drive Cube forward, and ultimately how we help you help others. That's really a large part of our goal here.